Okay, physics people, we're back with another one-dimensional kinematics problem. This time, a more traditional problem in the sense that it's a stone dropped from a cliff. And trust me, the more problems you do, the more problems you're going to see like this one. Okay, so a stone is dropped from the top of a cliff. It hits the ground below after 3.24 seconds. How high is the cliff? Okay, same start as every other problem. Draw a picture. And like I always say, I'm not an artist. You definitely don't need to be either. Okay, so that's my cliff. Okay, a stone is dropped, so that's going to be my stone. Okay, we want to know how high the cliff is, and this stone is going to drop eventually. It's going to hit the ground, so you know what? It's going to travel a certain distance. So the height I'm going to represent with the letter D. Now, there's something in this question, a key word that really gives a lot of information away. Okay? Something that you have to get used to recognizing, and that is the word dropped. Okay, whenever you see the word dropped, that means initial speed is 0. Okay, so V naught equals 0, okay, meters per second. That's the best, because at first glance it looks like this problem only gives you one piece of information, that it takes 3.24 seconds to hit the ground. Okay, so that t equals 3.24 seconds, and you're probably wondering, how do I find distance only with time? Well, like I said, there's a hidden piece of information in the problem, and that it is dropped, and there's one more. And this one is rarely given to you in the problem, and you have to realize it on your own, and that is this. Okay, this stone is falling, and obviously it's speeding up as it falls. When things speed up, they're accelerating. Okay, now you ask yourself, well, accelerating due to what? Okay, it's accelerating due to gravity. Okay, gravity's making it speed up. It won't speed up if you throw it up. It speeds up if you throw it down. So we can actually say that the acceleration is the acceleration due to gravity g, which is 9.8 meters per second squared. Okay, now we're trying to find how high the cliff is. So pretty much what we're trying to determine is the distance it travels through this acceleration in that much time. Okay, so the kinematic equation for distance is d equals v naught t plus 1/2 a t squared. Okay, so a few simplifications to start with. We know v naught is 0, so that's handy. 0 times anything is 0. So this entire expression goes away. Okay, so we're left with something a lot simpler. Now, before I actually write the next line, there's one more simplification I can do. Okay, you see that acceleration there? I labeled it as g over here in the diagram because g is the acceleration due to gravity. Okay, when you experience several g's on a roller coaster, or pilots that experience a few g's, it's referring to how many times the acceleration due to gravity are they accelerating by. Okay, so here, the acceleration is g. So therefore, d equals 1/2 gt squared. Okay, pretty straightforward. Okay, so all you have to do is plug in your values. Okay, so 1/2 times 9.8 meters per second squared. The time it takes to fall is 3.24 seconds. Make sure you square that. And you end up with d equals 51.4 meters. Okay, and that's it. That's it, guys. I'm telling you, that was a really simple question, especially compared to the last one. Okay, so guys, if you liked the video, be sure to hit that like button. Subscribe to my channel if you want to see more and longer physics solutions from me. Okay, and if you think there's someone who can benefit from watching this, be sure to share it on Facebook and on Twitter. As always, I appreciate the views, guys, and I will talk to you later.